So in the previous class, we have seen a overhanging beam which is subjected to like point loads. Here it is a overhanging beam, and we had point loads which are acting on this beam. Okay, the intensity of load which is given as 20 kilonewton over here. The point load which is acting 15 kilonewton at this point. Here it is 10 kilonewton, and we have calculated this is nothing but section A, this is B, this is C, this is section D, this is section E. We have calculated the reaction force which is acting at RA, that is nothing but 11 kilonewton. This is 11 kilonewton. And at RD reaction force at D, which is nothing but how much here? 34 kilonewton, right? 34 kilonewton. So the distance we have noted down, the distance from here to here, from here to here, what is the distance over here? It is 2.5 meter. This distance is 1.5 meter, this is 1 meter, this is 1 meter, right? So for this we have calculated bending moment. Okay, bending moment at a point E is 0, right? Bending moment at a point D, bending moment at a point D, we have calculated it is minus 10 kilonewton meter. Okay, bending moment at a point C, bending moment at a point C, we have calculated in the previous class, right? In the previous class we have calculated the bending moment at a point C. What is the value here? It is 14 kilonewton meter. Bending moment at a point B, at a point B we have calculated it is 27.5 kilonewton meter, and bending moment at a point A is 0. So these many data we have calculated in the previous class, right? Now here once we get this bending moment values, the next step we need to draw the bending moment diagram. We need to draw bending moment diagram. To draw this diagram, what we need to do? First, we need to take a reference line which is parallel to the given beam, which is parallel to the given beam. So for this beam, we'll draw a parallel line. This is the parallel line. Okay. Now, which is parallel to the given beam. Once we define this, so the next step we need to define the sections for this. Like from here, if you take this as section A, so this is section B. Similarly, this is section C, this is section D, this is section E. Okay, once we define this, so the next step we need to draw the magnitude values of this. At E we have bending moment 0. At a point D, what we'll do, like we need to draw this diagram, this line somewhat above of this, because we have minus value right here. At point D we have minus negative 10, so you better draw this line over here. Okay, because we have negative value which we need to show below of this line, below of this reference line. Okay, at point E we have 0. Okay, at a point D we have minus 10, so 1 centimeter over here. At a point C we have 14, means 1.4 centimeter. At a point B it is 27, positive 27, you can draw like this. At a point A it is 0. Now you can mark here, it is 0 here. Here it is 10 kilonewton meter. Here it is 14 kilonewton meter. Here it is, what is the value here? 27. 0.5 kilonewton meter. Okay, once it has been done, the next step, whenever we are joining the lines in the bending moment diagram, make sure that if you have point load, the line should be the inclined line. If in case if you have UDL, uniformly distributed load, then we'll get a parabolic curve, but here we have point load, so we'll get inclined line. So from point A to B we have point load, from here to here it should be an inclined line. Okay, and from here to here again, from point B to C it should be an inclined line. Okay, from point C to point C to D it should be again an inclined line. Okay, at point D to E it should be an inclined line. So once it has been done, the next step, you make it you hatch inside the hatch it like this. So this is the positive, this is the negative. Okay, the thing is, as we have discussed in the last class, the point of contraflexure. What is point of contraflexure? Point of contraflexure in the sense, the point where the bending moment changes its sign. So here at this point you can see the bending moment changes its sign, means from negative to positive it is changing its sign. So at this point the bending moment is changing its sign. So this point we will call it as some name. Let us call it as by the letter S. Okay, or you can call by the letter F, no issue in this. So let us call with the S. So this is nothing but this point is the point of contraflexure. The thing is, we need to determine what is the distance from this. What is the distance from the E? What is the distance from the E to S? This thing we need to determine. So how can we determine this? We need to determine the value of x, means if we determine the value of x, we can easily tell the point of contraflexure at which occurs at this point at a distance of x from the point E. So we need to determine what is the value of this, what is the length of this. How can we calculate here? How can we calculate this point of contraflexure? Any idea? Any idea? See, you can calculate this point of contraflexure by this formula you can call by this condition. As we know that at this point means on this line, on this reference line, the bending moment is 0. Okay, means bending moment at point S, which is equal to 0. At this point it is 0 because at the reference line bending moment is 0. So bending moment at a point S is 0, which is equal to here, which is equal to, we can say, for example, this bending moment may occur somewhere here. So this we call it as S. Now we need to calculate what is the moment at this point. What is the moment at this point? How can we calculate here? So we can calculate by considering what are the forces acting right to this. So we have 10 kilonewton and we have this 34 kilonewton. So I can write my downward acting forces is nothing but negative 10 kilonewton into from here to here. From here to here, it is the distance is x. Okay, this distance is x. Now into x, we have this force, right? That is nothing but positive 34. Now, what is the distance from here to here? We can write 1 minus x here. Sorry, you can write x minus 1 over here. If you subtract x minus 1, you will get this distance. Okay. Now you simplify this equation. 0 is equal to minus 10x plus 34x minus 34. So x is equal to, you will get around 1.417 meter. You simplify this, you will get the answer. So the point of contraflexure occurs at a distance of 1.417 meter from the point E. This is how we need to determine the point of contraflexure. Okay. Any doubt here? Any doubt? Okay. I think you are very much familiar with this. I hope so you understood the class. So if you have any doubts, you can ask me shall we end the class now? If you have any doubt, you can ask me, like you can text me later onwards. So we can discuss this. Okay. Shall we end the class now?